Hi everyone, I hope you're all having a good summer. So in this video I am going to be going over questions that are similar to your summer homework page. Next to them I put their light questions 1 through 9 so that way you'll know what to refer back to. I'm not doing the actual questions on your summer homework because you need to do those. So if you're working on these and you don't understand what I'm saying, or if you're working on your actual summer homework problems and you need help, you can email me at misswarnermathhelp@hotmail, and I should respond within a day or two and be able to help you answer your questions. Sometimes it helps if you take a picture of what you're working on so I can see your work, and then email me that so I can see what you're doing. Okay, so let's dive right in. So our first problem is solving a multi-step equation. So remember, the first thing we always have to do is get rid of parentheses, so we'll use the distributive property. So we'll distribute here. Remember, distribute means multiplication. And then we'll distribute here. Be careful with your negative signs. So the next step would be to get any like terms on the same side, which we only have these two right here, so we'll combine those. Again, be careful with our negative signs. So now we have to get like terms together that are on opposite sides of the equation. So we have x's on both sides. So I'm going to subtract to get those x's together first. It doesn't matter if you would have subtracted the 8 or the 3. I always like to subtract where it's not going to make it negative. So I always subtract the littler one. And now we have to get the number on the other side. So now I'm going to move over here. We have 15 equals 5x. So our last step would be to divide by 5. So 3 equals x. So most of the ones on your worksheet are just like this one. So if there's parentheses, do distributive property, combine like terms across the equal sign, combine like terms across the equal sign again, but with the numbers, and then your last step should be division. So for the next set, we have a proportion. So remember, we cross multiply when we're solving a proportion, but first, if there's a binomial where it has two terms, we're going to put it in parentheses and then cross multiply it. So we have 7 times that parenthesis equals 4 times that parenthesis. A common mistake here is that once people cross multiply, they try to put those answers as fractions. So this over that, but that's not an equation anymore, it's just a fraction. So that's not what we're supposed to do. We bring down our equal sign. So that goes to one side, and then that'll go to the other side. So once you cross multiply and don't have fractions anymore, the steps that we do are just like what we did for the first set. So we'll distribute and then combine like terms. So we have 3x equals negative 26, divide by 3. Since we can't divide that by 3, we're just going to leave it as a fraction. So answer would be negative 26 over 3. Don't change them to decimals, just leave them just like they are, okay? Okay, so our next set is like questions 16 through 19. And those are how to how to add or subtract fractions. So what I like to do is to change everything to an improper fraction first. So remember, we times the denominator to the whole number, and then we add it to the numerator. So 3 times 2 is 6, plus 1 is 7. So we have 7 thirds minus 15 plus 4 is 19 fifths. So from here, we need to get our common denominators. So what I do is I just times this fraction by this denominator and this fraction by that denominator. So the denominator to times here is 5, and we'll times this one by 3. So we end up with 35 over 15 minus 57 over 15. And then we just have to subtract the numerators. Remember, when you're doing addition or subtraction of fractions, the denominator stays the same. So just combine the numerators, this part here, and keep the bottom the same. So the only other thing you would have to do is check to see if you can reduce, and this can't be reduced. So that would be it for this problem. So for multiplication, like the next set, we kind of start out doing the same thing. We have to change them to improper fractions. So 5 times 7 plus 1 is 36 over 5 times, I think it's a 9. So that'd be 27, 28, 29. And there was a negative sign there. So for this, a lot of people, when they times, they'd say, okay, it's negative 27 plus 2 would be negative 25. But that's not really how it works. Just when you're doing that, forget about the negative being there, and then change it, and then just put your negative back. Okay. Okay, so with multiplying fractions, we just multiply straight across. The only time we call it cross multiplying is when we do this, because we're crossing. Okay, we don't do that here. We could just go straight across. So 36 times 29 is something I don't know off the top of my head. It's at 1,444. So again, we'll check if we can reduce it. Since we had factors of 9 in our original problem, that means we can reduce by 9. So we get negative 116 over 5. And that would be our final answer. Okay, so division is a lot like what we just did. Change to improper first. So it's 15, 16, 17. Negative 17 over 5 divided by negative 4 over 3. So with division, to get rid of the division, we change it to a multiplication. So we multiply by the reciprocal. So there's a couple different sayings that would help you remember. Keep, change, flip is what I like. So the first one, or stay, change, flip, or something along those lines. So the first one stays the same. We change the sign to multiplication, and we flip over our fraction. We could have left the negative sign on the top, which is what I usually do. I don't know why I moved it. Okay, so then we multiply straight across since we changed it to multiplication. So 17 times 3 is 51 over 20. Remember, a negative times a negative is a positive, and there's nothing to reduce those by, so that is it for dividing fractions. But always check to see if you can reduce first. Okay, so that was like 24 through 27. So our next set is simplifying radicals, and this is something we're going to be doing a lot, so I really hope that you guys understand this part. So there's several different ways that you can do this. You can try to find the biggest perfect square that can divide into this and divide it by that. Or you can just make a factor tree and see what the factors are for that number. So that's what I like to do. So I just take our number, and divide. If it's even, I'll start just by dividing by 2. So divide by 2 again. We get 189. Try to divide by 3. 21. And that's 3 and 7. Okay, so if your factors are confusing listing them like that, you can list them out just like as time. So take all your leaves that don't have anything coming from it. So this is equal to 2 times 2 times 3 times 3 times 3 times 7. So now what we're doing, we're looking for pairs of numbers that are the same. So we have one pair of 2s and we have one pair of 3s. So if the numbers are the same, one from that pair is going to go on the outside of the radical. So I have 1, 2, and 1, 3. If they don't get circled, then they have to stay inside the radical because they didn't have a partner. So it would end up like that, and then we would just times to finish. So this would be 6 times 21. And that is it. So the circled things, these go on the outside, and then the things that don't have a partner go on the inside. Okay. So the other radical stuff that we're going to do is called rationalizing the denominator, which is like questions 38 through 40. And these involve when we have a radical in the denominator. That's like an I was going to say improper fraction, but it's not, well, technically this is an improper fraction, but it's not the same thing. We're just not allowed to have a radical in the denominator. It's one of those math rules. So we have to do the process of rationalizing the denominator to get rid of it. So if you think about the properties of radicals, when you times a radical by itself, you end up with something that's a perfect square. So if we do root 2 times root 2, we get root 4, and root 4 is just 2. So if you times a radical by itself, you don't have a radical anymore. So that's what we're going to use to get rid of the radicals in the bottom. But we can't just, if you remember anything about fractions, we can't just times the bottom. It's something we have to do to the top too. So we would times the top by that radical. So we'd end up with 3 root 2 in the top, which is still just 3 root 2. That can't be simplified at all. So this would be our answer. Okay, and we got rid of the radical in the bottom. So again, to get rid of a radical in the bottom, you times the top and the bottom by that radical. So let's try it for this example over here. So our radical in the bottom is the square root of 7. So we'll do it to the bottom and the top. So we get 28 square root of 7 over the square root of 49. So we can times these together because they're both inside a radical. These don't get times except for like this, because they're not both in a radical. They're not like terms. So if we simplify the bottom, the square root of 49 is 7. And then for this one, we can go one step further because 28 over 7 is just 4. So we can reduce our fraction and we would end up with just 4 root 7. If we look at the first one that I did, we can't divide 3 by 2 and get a whole number, so we just leave it as a fraction. Okay, so for the next set, it's like questions 43 through 48, and this is using the Pythagorean theorem. So remember, a squared plus b squared equals c squared. So we just plug in our numbers, so we'd have 7 squared plus b squared equals 15 squared. So that means for this problem, we're solving for b. So we're trying to find the value of b. So remember, in the Pythagorean theorem, these numbers represent sides of a right triangle. And C is always your hypotenuse. So this would be angle C. So if this is A, it's 7, and then that would be B. So this is side B that we're trying to find. Okay, so anyways, square your numbers. So we have 49 plus B squared equals 225. We're trying to solve for B squared, so we have to get the numbers all together. So B squared equals 225 minus 49, which is 176. And then, I don't know if we remember from algebra, but the way we get rid of a square variable, we don't divide by 2 because this really means B times B. So what times itself equals 176? This number isn't a perfect square, so we'll just do our radical thing. So that cancels the 2. So we end up with B is equal to the square root of 176. And then we should try to make a factor tree to see if we can simplify this. So we would, like what we did for this part up here. So I'm going to factor tree 176. So 176 divided by 2 is 88. Divide that by 2, we get 44. So it's 2 and 22, 2 and 11. Okay, so now remember we're looking for couples. So we have one couple here and one couple here. So that means that we put one from each of those couples on the outside, and 11 doesn't have a partner, so it stays on the inside. So our final answer would be 4 square root of 11. If you're having problems with that radical part, you should look up on YouTube simplifying radicals, and I'm sure you will find a lot of other videos that'll help you figure it out. Or again, you can email me. Okay, so on 49 through 58, we're graphing. I didn't get any graph paper for this. I'm just going to sketch it on here. You should really try to use graph paper though. It'll help your graphs be more accurate. So for the first one that I'm going to show you is graphing a y equals mx plus b. Okay, so this is m and this is b. So remember, we always start with our y-intercept, or b, and we put that on the y-axis. This is y and this is x. So we'll put a point there, and then we'll do our slope. So remember, if our slope is 1/3, we have rise and run. So we're going to go up 1, and we always run to the right. So I'm going to go up 1 and run 1, 2, 3. So you only really need 2 points. You can keep going if you want to get more points on there. We can even do it the other way. So if we go the other way, we would do the opposite. So I'm going to go down 1 and to the left 1, 2, 3. And then that is our line. Okay, so for the second one, these are just graphing horizontal or vertical lines. Okay, so I know everyone always mixes up which way we do this. So think about if this is our y line and this is our x line, where is y going to equal to? Well, that would be here, this right here. But it's also at all of these other points here. It's like this point would be 1, 2, this would be 2, 2, this would be 3, 2. So the line of y equals 2 is actually a horizontal line through that y value of 2. And that's it for that one. So if we think about that same idea for x equals, so x equals -3 over here, and all these points going up. So this is -3, 1, -3, 2, -3, 3, -3, 4. Okay, so x equals a number is a vertical line. We're going to be doing a lot of these when we do transformation, so we really need to understand that idea. Okay, so for our last one, this is our m and this is our b. So that means we'll start by going up 4, putting a point. So if our m is equal to -2, we need a fraction to get our rise over 1, so we just put it over 1. So we're going to rise and run. Since our rise is negative, that means we'll go down 2, and we're still always run to the right. So down 2 over 1, down 2, or down 2 over 1. Okay, and that is our line. Awesome. Okay, so let's take a look at the back. This is on the back page. I listed your area formulas for you there. It might have been a while since you've done area in 7th or 8th grade, maybe 6th grade. So we really just have to plug into the formula. So this is a trapezoid, and the formula is 1/2 times the height times the basis. So in a trapezoid, it has 2 bases, okay? And you can tell which sides are the bases because they're always parallel. So they're the same distance apart. And they end up being perpendicular, which means it makes a right angle with the height. So that means that this is a base, and this is a base, and so this will be our height because it's the perpendicular side. These 2 sides over here, they don't mean anything, and we're not going to use them for our area, okay? So this is 1/2 times 4 times 7 plus 12. So if you do PEMDAS, you would do parentheses first, but you can do this at the same time. So I'm going to do 1/2 of 4. So 1/2 of 4 is just 2. Another way to think of that is to do 4 divided by 2. And then I'm going to add those together. So I'll have 19. And 2 times 19 is 38. Our units were inches, so we have inches squared. So our area for that trapezoid is 38 inches squared. Okay, so for the circle, our formula is pi r squared. So remember, r represents the radius, and our radius is from the center to the circle. So the line that they gave us is not a radius. It goes from the circle through the center to the other side of the circle. So that's called the diameter. So a radius is half the diameter. So this part right here is a radius. So if the diameter is 20, then that means our radius is going to be just 10. So we'll plug that in here. So the area is equal to pi times 10 squared. 10 squared is 100, so this would be 100 pi. And I'm pretty sure on your directions it says to leave your answers with pi. It doesn't say. So usually I just leave it just like that. So our answer would be 100 pi feet squared. If it doesn't say, it's safe to leave it with pi. I mean, you can multiply the pi out, but then there's always the rounding issue since pi goes on forever. So I would just leave it just like that with the pi in it. We'll talk more about that when we get to area and stuff. Okay, so our last area problem is a triangle. So the formula for a triangle is 1/2 base times height. So there's a lot of stuff going on here, okay? So if there's a picture like this, you have to remember that the triangle is actually just the shape that has the solid line. So that's our triangle we're trying to find the area for. Our height is always perpendicular to the bottom. So since we couldn't get the top point perpendicular to the bottom inside the triangle, we had to put it on the outside. So those dotted lines don't represent any part of our triangle we're trying to fan the area for. It just shows us how tall from the bottom to the top our triangle is. Okay? So this is our height then. And then this part is where it's perpendicular to, so that's our base. So we have 1/2 times 32 times 18. So half of 32 is 16 times 18, which is 288 meters squared. Okay, so our last section is finding volume. So again, we should have done this sometime in middle school. Your formulas are right there on your sheet, so you just have to match them up. So this is a cylinder, or sometimes called a circular prism. So it says that your volume formula is equal to pi r squared h. So we'll just plug in our numbers. So pi, our radius is going to be the radius of the circle, which is the bases for our cylinder. So that'd be 9 squared, and our height is 42. So we'll have pi 81 times 42, which I don't know that off the top of my head. So my calculator tells me it's 2,000, it's JK, 3,402 pi kilometers. And this is volume, so it's not squared anymore. Volume is actually cubed. And we'll go into more of that, why all that's true in class when we finally get to volume and surface area and stuff. Okay, so that would be it. Remember I said to leave your pi's there, don't times them out. Your pi's like this day. Okay, so for our last shape, this is a rectangular pyramid. It's called a rectangular pyramid because the base is a rectangle. I know I kind of drew it like a square, but we know it's not a square because the sides are different lengths. So the formula for a pyramid is 1/3. It says length, width, height. Okay, so we have 1/3 length, width, and then height. So it would be 15 times 10 times 21. So for this one, you could do 1/3 of 15, since 15 is a number divisible by 3. I'm just going to do that. So 1/3 of 15 is going to be 5. So 5 times 10 times 21. So 5 times 10 is 50, times 21 is something I don't know. 1,050 inches cubed. Okay, so that's it. So I hope that that helped you answer any of the questions that you had to complete your summer homework. Make sure you showed all your work. As you can see, all these problems involve doing something. Okay, so show all your work or you're not going to get credit for your summer homework. So show your work. Remember, you can email me if you have any questions. And that is it. I hope everyone has a good summer.